Okay, today we're going to do a few more problems to help us practice and get ready for our test. So, let's take a look at this. First one, we're going to solve this proof, and notice that what the proof statement says, it doesn't say the triangles are congruent. So that means that we're going to have to prove the triangles are congruent and then do something else after it. So let's first focus on proving the triangle is congruent. So AC is perpendicular to BD, so I've got right angles. And BD bisects angle ABC. So let's just look for a second. Here's angle ABC. And BD cuts it in half. So it's these angles that are congruent. I'm going to erase that yellow line because it's confusing. Alright, so let's label our facts. So here's an angle. Here's another angle. And here's our side. So the method we're going to use this time is angle, side, angle. Yes, it's a right triangle, but we don't know the hypotenuse and the legs. We can't use HL. Alright, let's start writing this in our proof. So I'm going to start with AC is perpendicular to BD. And our reason was given. Now, when we read that it was perpendicular, we marked that we have right angles. So let's write which angles are right. Well, the angles that were right would be angle ADB and angle BDC are right angles. Okay? And we knew that because we knew the definition of perpendicular lines. Alright, now, when we're using angle, side, angle, we can't stop at right angles. We can only stop at right angles when it's hypotenuse, leg. So we have to take that a step further. So now that we know that they are right, now we can say that they are congruent, and our reason is the right angle congruence theorem. Okay? That gives us what we marked in our picture as angle 2. Now we need a couple more facts. Well, we know that BD bisects angle ABC. That was given. And when we learned that, we marked congruent angles on the picture. We marked angle ABD congruent to angle CBD. Now our reason. Now let's look at the statement before. The statement before, we're talking about an angle bisector, and then we were able to write the congruent. Well, we know the angle bisector. Nope, not theorem. Oops, wrote the wrong one. Definition. Alright, so this on the picture is what we marked as angle 1. We're still missing a fact. Well, that's the side in the middle. So we have BD is congruent to BD, and the reason is reflective. Okay? And there's our side. So now we have all three facts. And I am totally out of room. Okay, I'm going to write it over here to the side. You can write it on another piece of paper, or I don't know what you're going to do. Okay, so now we've got our three facts. So now we can make our conclusion. Alright, keep going. So we know that triangle ABD is congruent to triangle CBD now. And our reason, well, the method we used was angle, side, angle. Alright, so now we have to figure out how we're going to make this prove work. Well, we know the next reason has to be CP, There's no other choice. So now we got to figure out what congruent parts we're going to match up. Okay, and since this doesn't say something is congruent to something, then we're going to have a congruent statement here, and this is going to be D is the midpoint of AC. So now we got to figure this out. So let's say, so we ask ourselves, if D was the midpoint of AC, then this segment would have to be congruent to that segment. So that is the key fact. So if we write in here, AD is congruent to DC. Well, let's look. AD is the first and last, CD is the first and the last. So that means they're corresponding parts, and they're incongruent triangles, so there must be congruent. So there the CP-C2C works. Okay, so now we know the cards are congruent. Now we can say this, that it's the midpoint, and our reason is going to be the definition of a midpoint. Alright, let's try the next one. Number 2. Number 2 says that EF is congruent to GH, and FG is congruent to EF. That doesn't make sense. Let's change that to EH. Now we can rock and roll. Okay, so now we've got those congruent. So if I'm looking for my congruent pieces, so I have segment 1, here's another side, and then my third side in the middle. This one's nice and easy. I can prove this by side, side, side. So now let's list the things in our proof. So the first thing is all those given. So we have EF is congruent to GH, and FG is congruent to EH, like we changed it to make it make sense. And that is given. Now we can say, well, what's our third fact? Because this was side 1, this is side 2, so we need our third fact. And our third fact is going to be the middle side. FH is congruent to FH, and the reason is reflexive. Okay, so there's the third side. So now that we have our 3 facts, now we can make our conclusion. We can say triangle EFH is congruent to triangle GHF, and our reason is side, side, side. Okay, but we notice, and you probably did from the beginning, the proof statement does not say triangle blank is congruent to triangle blank, which means we have to go further. So we know this next reason has to be CP-C2C. And since this doesn't say something is congruent to something, we know that it's going to have to go 2 steps after the triangles are congruent. And this is going to be EF is parallel to GH. That looks funny. Let's try it nicer. Parallel to GH. So now that we know that, let's see if we can fill in the blanks. So if EF was parallel to GH, so if the left was parallel to the right, then this would be our transversal, and these 2 angles here would be congruent. Well, that's kind of like F and H. Oh, look, they're in the same spot. That must be their corresponding parts in congruent triangles. So therefore, they're congruent. Alright, so these green angles are the missing piece. So we need to say angle EFH is congruent to angle GHF. So these were corresponding parts in triangles that were congruent, so therefore we knew they're congruent. Well, these green angles happen to have a name. They're alternate interior, and when alternate interior angles are congruent, we know the lines are parallel, so now we can say that the lines are parallel by the alternate interior angle converse. Okay? If you can't remember which one's which, if you're above where the triangles are congruent, that's the theorem. When you're below, you're going to use the converse. Okay, if you can't remember why, just remember that part. Alright, let's look at some easier problems to practice. Oh, number 3. Everyone missed this on the quiz because they forget what to do. The rule says that the exterior angle equals the sum of the 2 remote interior angles, which means 116 minus x equals 2x plus x. Okay, let's simplify that. That means 116 minus x equals 3x. So 116 equals 4x. So when I divide by 4, I get x to be 29. Alright, example 4. We know this is an isosceles triangle, so that makes these the 2 legs. The third side has to be the base, and the 2 angles touching the base are the ones that are congruent. Okay, so we don't know this angle, but we can fill it in because we know it's x plus 20. So now we know something about all three angles in a triangle. And all three angles in a triangle add to 180. So I can add these together to 180. I'm going to do this in my head. 3 and 1 would be 5x. 20 and 20 is 40 equals 180. So now I get 5x equals 140. So when I divide, x is 28. All right, let's try this in. No problem. Number 5. Okay, we've got another isosceles triangle. The two sides that are congruent are the legs. The other two sides, so the third side is the base, and the two angles touching the base are congruent. So that allows me to easily find x. So I'll say that x plus 20 equals 2x minus 10. So when I solve, I get x equals 30. So that's that part. But now I need more information. Well, if x is 30, I can find these angles. 30 plus 20 would be 50. So that angle's 50, that angle's 50. If all the angles in a triangle equal 180, that means this angle equals 80. So I have 4y equaling 80. So y comes out to be 20. Okay, number 6, another isosceles triangle, but not just any isosceles triangle, it's an isosceles right triangle. So I know that these two angles are congruent, and they're in a right triangle, so they've got to equal 90. So I'm going to take 90 divided by 2, and I get 45. So each of these angles are 45. But now I need to get y. Well, y and 45 are a linear pair, which means they add to 180. So if I do 180 minus 45, that gives me 135, which is y. Okay, and then x here to here is 45. Alright, last example. Let me draw a picture. We have an isosceles triangle, so we're going to draw a triangle. We're going to mark our two sides congruent so we can get our point. Now we need to label. C is the vertex, so C has to be the one here. A and B have to be the other two. Then label my sides. I've got 3x minus 6, and BC is 15, and AB is 18. So now that I've drawn the picture, it's very easy to see that these two sides are the ones that are equal. So to find x, I'm going to do 3x minus 15. Now the reason I didn't set them all equal to 180, they're not angles. So I get 3x is 21, divide by 3, so I get x is 7. Okay, sorry about the background noise. My son was sitting next to me yawning. Have a good day.